we have a cumulative frequency curve, and it shows the speed in kilometers of the 80 cars that were going along the road. So the first question says to calculate the percentage of the cars that exceed the speed limit of 80 kilometers per hour. So 80 kilometers per hour is found here, and all we're going to do is draw a nice straight line with a ruler, and we can see that it crosses at an exact point. And then again, using a ruler when you draw this, and we can see it crosses there at 72. So that means that there's 72 over 80, which is 90%, 0.9, so 90%. That's the amount of cars that are going the speed limit. That's the majority, and therefore there's these 8 over 80, which is 10% that were speeding. So our answer there is 10% of the cars were speeding. Then we need to work out the values of P, M, and Q. So they're the boundaries between our groups. So to do this, we're going to need to again draw lines onto our diagram. And the first one is that we have 20 cars. So 20 cars, if I go across from here, so there's 20 cars in the first group. That means that the first group goes up to 44. So this value here is 44. And let's write them onto our diagram or onto our table so that we have them later if we need them. So 44. And then the next group is adding on 20 more. Okay, this is the frequency. So I'm adding on 20 more. So this would take me to 40. And again, I can use my diagram. And I can see there that that takes me to 60. So if I write that into my table, that means that my group is 44 to 60 and then 62. And then this one, I need to work out what it goes from. So 60 to whatever. I'm going to add on another 20. And that takes me to 60. Which takes me to exactly 70. So I now know that my last number there is 70. And again, I can just write that into my diagram or onto my table. So I now need to estimate the mean of the cars. We know that to work out the mean, we can go to our calculator and we go to statistics and then edit. To do that, we need to know the data value and the frequency. We know the frequency is 20, 20, 20, and 20. We had that here, the second row of our table. But we need to know the data point. At the moment, we have grouped data. So it goes from 0 to 44, from 44 to 60, 60 to 70, and then 70 to 100. When you have grouped data, you need to estimate it with a midpoint. So that means that we now need to find the midpoint of all the data. So between 0 and 44, it would be 22 as my midpoint. And if you're not sure, then on your calculator, you can just add the upper and lower bounds together. So 0 plus 44, and then you can divide that answer by 2, and we can see there. So for the second one, if you weren't sure between 44 and 60, it's 44 plus 60, and then divide that answer by 2, and you can see that it would be 52 as my midpoint. And if I keep doing that in the same way, I have a midpoint of 65 and a midpoint of 85. So the mean between them, I would go to my data and statistics and then edit the data. And you can see here I've put my data value as the midpoint, 22, 52, 65, and 85. And my data point as 20, 20, 20, and 20. And now we need to work out the mean. So I'm going to go to calculations, and I just have one variable. My variable is speed. So the list of the data is in list 1, and then the frequency is found in list 2. So I now need to add on list 2, so L2 is this one here, and then I can calculate it. And my mean is this one right at the top, the X with the bar on it, which is 56. So if I go back to my exam paper, I can see that the mean of the data is 56 kilometers per hour. So for this one, there would be 1 mark for finding the midpoints, and then 1 for the units and 1 for the answer.